Welcome to the speed round of running through our calculator calculations to get reactant order and eventually rate laws. You need to be given concentration and time data in order for this to be a useful strategy, and just what I say, time and concentration. The other type of data you are likely given is a different type of problem that involves concentrations and rates. So take note, this graphical method is what you're going to use when you're given time and concentration data. And our goal here is to run through these steps. So pretending that this was a time and concentration data problem that you were given, we said stat, right? You want to edit your lists, and again, I cheated in advance and typed in all of those time and all of those concentration values. And I also want to calculate the natural log and 1 over the concentration, because those are the graphs that are potentially going to give us linear functions. So in this one here, just go up to the top. I'm going to hit the natural log of our concentration, which was L2. And then I'm going to go up to the top of the column for L4. I'm just going to hit 1 over our concentration, which is L2. And I'm going to point out, like, a very common mistake is to get to your list over here and then accidentally type in L3. You want to make sure you're using the concentration both times. And in this case, I had the concentration set as L2. All right? We can then jump to second y equals enter. So y equals, second y equals is going to give us stat plot. We want it, and we're going to set the x list and the y list as the data for time and either concentration or natural log concentration or 1 over concentration. So the first time I'm going to try time versus concentration. That was our L2 value. And then I'm going to graph it. So we can go to graph. Don't see it. You may recall me mentioning zoom 9 gets us there. It doesn't look super straight. All right, I mean, it's got a distinct curve to it. We can check real quickly how straight it is if we look at the stat function. We can calculate a linear regression, and in this case we'd use L1 and L2. And I don't think we're going to get a very good R squared value, 0.95, which at first glance might seem pretty good, but you may recall from the last video, 0.99999 is what we would call pretty good. All right, so we have ruled out concentration, 0 order, so now let's try natural log of concentration, which would be first order. So I'm again going to go to the stat plot, second y equals, and instead of L1 and L2, now I'm going to try L1 and L3. We'll graph it, zoom 9. That looks pretty straight, all right? And I'm not super confident that it looks pretty straight, so we can always check with our linear regression. So stat, move it over to calculate, drop down to linear regression, and I want to do linear regression on L1 and in this case L3, the one I was just using. And we see R squared value of 0.9999, so very likely that in this particular case we have natural log of concentration versus time linear, which is giving us first order with respect to that reactant. We also here then have our slope, which is negative 0.007, and that's going to be our rate constant. The absolute value of that will be our rate constant. And then for our B value, it's going to be 1 over, or sorry, the natural log of the initial concentration, and that is right there. So so we'd be done. We'd plug that data in and then start using it. That's how we get that data. But I just want to take a glance at that last graph. Let's say, and I always check all 3 because inevitably I get impatient. So L4, graph it, zoom 9. That is not straight. And if I doubt if it's not straight, I just go to stat, calculate a linear regression, L1 and L4 in this case, and that's 0.95 again. So actually, our first graph and our third graph for 0 order and second order, given R squared around 0.95, which is not as close as the 0.99999 value. All right, once you have that data, then you can use it, but this video is about how to get that data from a calculator.